We use the properties of sampling distributions in order to build confidence intervals. So in example 2, we're going to work with the confidence interval for a true population mean, and in order to do that, we use the characteristics of the sampling distribution for the sample mean. So those characteristics, you can find 2 of the 3 on the formula sheet. So on the second page of the formula sheet, down here you'll see that the center or the mean for the sampling distribution, for the sample mean, is the true mean that we're trying to capture with our confidence interval, and the standard deviation, so of the sampling distribution for sample means, is the population standard deviation over the square root of n. This is the standard deviation that we will be using in our confidence interval. So here, what sample mean is, what sample size is needed in order to create a 95% confidence interval for the mean math SAT score for seniors from Hamilton County. And I want a margin of error of plus or minus 20 points. So something else to think about. If you take a look on the formula sheet, you can see on the third page of the formula sheet, you're given the structure of a confidence interval. So here is the statistic. In this case, it would be a sample mean, but we don't really need that. Here's the margin of error. We're adding and subtracting our critical value times the standard deviation of the statistic. And notice it's repeated down here. So here's the standard deviation that we will be using. And our critical value, we're going to be able to use z-scores. Often when we work with inference regarding means, we work with t-scores. Well, this time we are going to assume that we know what the population standard deviation looks like, and that way we can solve for our sample size. So we'll go back and take a look here. So our margin of error that we want is plus or minus 20 points. So I'm just going to write that as 20. So we're going to use a critical value. In this case, we're going to use a z-score because we're going to assume that the standard deviation for the population is 110 points. So that means that the sampling distribution's standard deviation is 110 divided by the square root of the sample size. And really, all we need to do then is find our critical value. We'll be good to go. So let's zoom in here a little bit. Here we go. So this is a z-score. I'm interested in a 95% confidence interval. So something to think about here. Recall, essentially, when I build this type of a confidence interval, I'm interested in keeping the middle 95% of the sampling distribution. So what that means is that we are eliminating the most extreme 5%, that's 2.5% on each side. So in order to find this critical value, I can either find this value here, which is the opposite of our critical value, or here's the positive version of that critical value. You can use the inverse norm command to do this. Remember, what the inverse norm command requires as its input is the percentile. So if I want to find this z-score right here, the percentile I need to put in is the 0.025. If I want to find the positive z-score, you could find either one, it doesn't matter. You would have to put in the 95% plus the 2.5%. You could put in the 0.975 into the inverse norm command. I think it's easier just to put in the 0.025. So second variables, inverse norm, 0.025 is the area. So you should recognize this z-score by now. This is 1.96 plus or minus 1.96, depending on which side of the distribution you're looking at. So either way, that gives us our critical value here of 1.96. So the equation that I need to solve then really looks like this. So my margin of error of 20, that's going to equal the 1.96 times the 110 over the square root of n. So this is all we need to solve for. So I suppose we could cross multiply this. So if I do that, if we cross multiply that, we'll end up taking the 20 times the square root of n, and then the 1 times the 1.96 times 110. There we go. So we'll divide both sides by the 20. And then finally, we can square both sides in order to solve for n. So we'll take a look at this here. Take the square of this, so we've got the 1.96. There's our critical value times the 110. That's the standard deviation of the population that we assumed, divided by the 20. That's what we want to square. Now, something important, when we solve for this, we want to guarantee a margin of error of plus or minus 20 points. So one of the things that means is we always round up. So when I substitute this expression into the calculator here, we're going to square this, the 1.96 times the 110 divided by the 20. We're going to square this. So you end up with 116.2084. Now, be careful. You don't want to round this in the typical way. So in order to guarantee that 20-point margin of error, I still need this 0.2084th, if you will, of an observation. So even when the value is less than 0.5, we always round this up. So really, the sample size that we want to guarantee this margin of error is 117.